Hi everyone, Zach here, and welcome to Lesson 13 in this series on developing a survival game. In this video, we'll set up some of our inventory functions that we need to give our inventory system some, functionality. This will be discarding our items, splitting our stacks, swapping stacks or items, and other various functions that we need to get our system fully up and running. This is the last pure blueprint scripting video we have in this section. After this point, we'll start working on our UMGs. That said, this series has been brought to you by my Patreon sponsors. And open up your projects, and let's make a start. Hi everyone, and welcome back to the editor. In this video, we'll set up some more functions for our inventory system. These functions will operate for things like splitting our stacks, discarding items, swapping items around. So let's get started. We're going to go to Core, Actors, Inventory, Inventory BP. We can close out the item master. And on our graph here, all we're going to do is create one custom event called Update Inventory. And this is just to cause a visual update in our UI, but we're going to make a lot of references to this update inventory. We're not going to add any functionality in this episode. We will add functionality down the road. But because we're going to call this in almost every function we're going to create, let's have it ready to go. So what we need in this is an input of our dear old friend here, Mr. or Mrs. Index Reference, which is, of course, of type integer. And again, all this is going to do is going to trigger an event, actually in our player, that will trigger an event in our inventory UMG that updates our slots. That's all. That's all this is for. So we don't have the UMG yet, but again, because we are going to be calling this so much, it's easier just to go ahead and put that in. We are going to start with our discarding of our items. So let's create a new function called discard item, and this is a utility function. It needs two inputs, our old friend and another old friend. So our primary old friend goes first of index ref, and then we need other old friend of amount. Now this is not amount to add like we've done previously, this is amount to discard. So we are going to promote both of these to a local variable. So this will be our index ref local. We will then have our amount local. And again, this is amount to discard. I almost wrote that because I was speaking it out loud. Oh, that would not have been that would have been a very long thing to write. So we are setting local variables. From there, what we need to do is we need to do a check. And this check is going to have two conditions we need to meet. And we're going to create a function for one of them. We'll create it outside and then collapse it down per my usual style. So first we need to know, is there something in the slot? And second, is there an amount to actually discard? Because a player might open the discard menu and go, oh, I don't mean to have this open, and hit OK. But if the amount is 0, we're not actually going to discard anything. So what we're going to do is put an and in. Sorry if you can hear the squeaky chair. That was my elbow hitting the armrest. And on this, we are going to do a check. We're going to take our amount local. Now, before I go forward, one thing we want to do with this is we're going to run off the false branch. We could run off the true, but I just want to run this off the false. So I'm going to do, is this less than or equal to 0? Because if it's less than or equal to 0, then we have nothing to discard. Also, let me just put a quick comment here of 1, is there something in the slot? 2, is there an amount to discard? I guess you could do these in either order because it's an and statement. It doesn't really matter what order they show up in. I'm going to get my index ref, and I'm just going to leave it outside of my comment area. And as I said, I'm going to create my function and then collapse it down. I'm also going to get my inventory slots. I'm going to get a copy of whatever's at this index. There we go. Just move that down there. And with that information, I am going to break our inventory slot. I'm going to take our item class, I'm going to do is valid. All right, this seems really familiar so far, right? Remember, I said we wanted to run this off the false branch. We can't just plug this into here. If we do so, if this is valid and this is false, then, well, we get a false. If this is valid and this is true, then we get a true, and that leads to other issues. So we want to kind of think about this in the inverse. We want there to be nothing in the slot. We want that to be a false statement. So we're going to do not. So this not will return the reverse of what we get here. So if there is something in the slot, this will be valid. We are then changing this over pretty much to a false. And that's all that is doing. And we're going to collapse this down to a function. This function will be called check if slot is free. And we can name this slot is free. Hey, we could also probably use this in other places. Hint, hint for things you can do to update. I'm just going to change that over to a pure function, because this is a pure function, at index ref. And there we go. We have our two checks. One, is there something in the slot? In this case, yes. So it's not free. This isn't a valid function, or this isn't a true statement. And do we have more than 0? Or sorry, do we have less than 0? If not, this is a false statement. We have something more than 0. My wording there got away from me. I apologize. I'm going to move this into my slots availability subcategory here, or category. It's not a subcategory. From there, we are going to have a return off our true, and our return is going to be a really simple one with one bool return of, I hate this chair, B item discarded. Or actually, no, we're going to do item removed. I mean, you can do discarded. I just prefer removed, because sometimes we're actually not going to be discarding the item. This discard item is polymorphic in that we'll be using it for actually discarding items and when we need to delete an item from inventory. So let's say you have a health potion. You drink said health potion. You need to remove it from the inventory. You're not discarding it, you're removing it. Thus my naming choice there. Next, what we're going to do is we are going to get our index local. And from our index local, we're going to get our class. How are we going to do that? Well, we're going to get our inventory slots data. We are going to get a copy at set index, and let's just move these pins underneath, or nodes underneath, and we are going to break this structural pin here. I mean, we could pull off and actually do a break. And when I said break, I meant to say split, but whatevs. You could break it. You could break or split it, your choice. And we are going to do item class local. So all we're doing is getting the class of the item. Why are we doing this? Well, what happens if we are dropping the item back in the world? We need to actually know what item that we are dropping back in the world, what the item we're dropping back in the world is. So we need to spawn it back into existence. Remember, in our item, we set its class. I'm going to give myself a little bit of space because I'm going to have the first part of the encumbrance system here. There's two parts to the encumbrance system for this. I'm going to put a branch in. So I'm just going to tag that spot, move that there, as encumbrance. And this is the first part, as I've already mentioned. And let's just, oh, I hate lining these things up sometimes. There we go. So this branch, we're going to check if discard amount is greater than or equal to amount in slot. In other words, we're dropping everything that's in that particular slot. Because if we are, we're going to do one thing. If we're only dropping some, then we will do something different. So what we're going to do is get our amount local. We are going to then get our amount in slot. I swear we created this at some point. So you might notice that something has changed here. I searched for the thing I'm looking for. I put it in the wrong area. It's this get amount. Get amount we need to actually move to the correct folder, which would be inventory items, not settings. So what we want to do is we want to see, is our amount local greater than or equal to our amount in the slot? If it is greater than, then someone's cheating. If it is equal to, then we are discarding the entire stack or the entire slot if it's just a one item thing. And we're going to plug that into the true there. We have two different events that are going to go on with our true and our false. Our true is easier. So if we are getting rid of everything in the slot, then we are adding item. We are adding item at the index local. And we are leaving everything else blank because we're now invalidating what's there and we're setting the slot amount to 0. That is fairly simple stuff, right? All right, let's just duplicate these nodes down here. And let's do our false. Our false is a bit different. So with our false, what we need to do is we need to take our index local. We need to get it. We need to get our item slots data. We need to get a copy at this index location. We are then going to split this pin because we do need both of the values in here. And we are going to update to that class. So we're not changing the class. And we are going to take the amount that we currently have. We are going to minus an integer from it. What are we going to minus from it? Well, that should be kind of obvious. We're going to minus the amount we want to discard. And we're going to take that and set that to our amount in the slot. Remember, the way this works is whatever we put in here is the number that shows up. It doesn't know to add or subtract. It literally just sets the number to whatever we put in. That's all. All right, next we have another branch. Because what we need to do is know, have we discarded this item or not? When we discard an item, we will set it so that we spawn the item into the world. If we use the item, say like a health potion, per my earlier example, then what's going to happen is the item is just going to be destroyed. It's not going to go into the world, it's just going to be gone. So we're going to create a new variable called b was discarded. We'll actually set up the functionality for the was discarded, setting it to true or false in a later video. We are going to set this to be a private function though, and we are going to, so that means that nothing else can access this. We are going to use a getter and setter to set our values for this. Only this blueprint will have access to that bool variable. This, as usual, will go into our bool category. And let's take this was discarded. I really hate this chair. Plug it under there. So all we're doing, check if item was used or dropped. Okay, now, I've said time and time again, we're practicing for when we go around things with the false. If this for some reason doesn't work, make sure you plug the false in. The number of people have gone, oh, I can't get something to work, I can't get something to work, and it's actually been they've skipped going around the false. So the thing to remember about this is, when you go off one of these branches, it doesn't know when the conditional statement ends. It just goes, everything in here I'm going to do. It doesn't go, oh, I'm only supposed to do the first node, or the first 2, or the first 20. It can't tell. You have to tell it. So, off here, all we're going to do to start with is spawn actor from, or spawn actor from class. Why wasn't that showing up when I typed in from? Okay, whatever. We're going to take our item class. We are going to plug our item class into there. And look, hey, there's our amount. Now, let's just do one more thing. I've said time and time again that, yeah, I know there's an error. I said time and time again that we are going to add something to our item. Let's go to our item. Let's go to our item master. We have to add one thing in here to make this fully work now. We have to add in a was discarded bool. So all we're going to do is add a b was discarded. And the was discarded is a, well, this one isn't going to be private. It's going to be exposed on spawn, and we want to be able to change each instance of it. And it is going to go into our bool category. Go ahead and save, compile, go back to here, refresh, refresh, refresh. All right, now I've mentioned time and time again about changing things. Go back to your item master real quick. Pop open this. Ooh, interesting. I know what the issue is. This really does have to be item master, and it does have to be the class file. Do that, compile. There we go. Hide unconnected pins, compile. That error is gone. We're done with that. Go back to your add item master, and I think the other one was this. It was this get max stack amount. Hide unconnected pins, compile, save. By the way, the error we're getting is because we don't have a spawn transformation here. We'll take care of that in just a moment. What we are going to do in our inventory is we're going to take care of the other stuff. We're going to pass in our was discarded, because that most likely is true on this point. But it's good OP to pass that in. Our amount to add is our amount local, because that's the amount we're discarding. All right. And now as for our transformation, what we're going to do is a little bit of a function here. And we're going to start it outside and then build it in. What we want to do is get the player's location and drop the item in front of the player. So we're going to do get player character. I hope that's all character, right? Get player character. We are going to come off of here and we are going to get actor forward vector. So we're dropping the item in front of the player. We also need, based on that forward vector, or in relation to the forward vector, the actor transform. So we're going to get actor transform. We are going to split this structure because we need all 3 pins. And we are going to move in front of the actor. So vector times float, and I do mean float, by 300 Unreal units. Oh, I put 900. So that is 300 centimeters. From 300 centimeters, we are going to add that value into another vector, and that vector will be our actor's actual location. So all this top part so far that we've done is saying is get the actor's location, find 300 units in front of it, start there. We are going to pull from here, and we are going to make transform. We are going to plug the actor's rotation in. We don't actually need to use the actor's rotation. We can use a different rotation. Now, as for scale, we're going to use the actor's scale. And the reason we're doing this is we know the scale is always going to be 1. It could be a particular instance of an item has a different scale, but we're going to use a default value, and the default value will come from our character's scale. We're going to take this return value and plug into our spawn transformation. We are going to select all these nodes. And look, this is a calculation going on in a pure function. We're just not storing or setting data, per something I mentioned in section 1. We are going to collapse this to a function called spawn transform discard item. It is, as I was kind of ranting about there, a pure function. We will place this function in our utility functions. We're going to drop this, just come on, move there. Let's pop this open. I actually kind of like how that looks, so I'm going to leave it as is. Did we do any other functions? We did this one. I am going to just move this down here now that I'm thinking about it, comment out. And what am I going to comment on this one? I am going to comment on this one. Oh, what am I going to say? If valid, the slot is not free. If not valid, the slot is free. I'm not sure. We'll ignore that typo. Okay. And notice the error is gone now, by the way, because we've put in that spawn transformation here. All right, next on our discard agenda, what we have to do is, well, we're going to just clear out our was discarded. So we're going to set was discarded now, because I missed the pin there, to false. And this is the end of our true statement. We will have to go around this and continue on with our false. So I'm just going to pull off this was discarded first. We're going to have our encumbrance system, and then we're going to update inventory. So just going to put that there for a moment. Put a reroute there. Come off this false from before the spawn our item. Or do it this way. And put some reroutes in so that it's obvious that we're going around this spawn item event. And we're going to have, as I've mentioned, the second part of our encumbrance system. So there's our encumbrance. We are going to update our inventory. We're going to do so at our current index ref. So we're just going to pass that out. Again, I know we haven't set that function up, but hey, we're done there. And speaking of which, we are done with this function. So there's our return node. We are going to remark this at this point as item removed because we haven't, at this point, we have removed the item. If we aren't able to do so earlier, we flag it earlier. All right, so the next thing we have to do is change our inventory slot. So we're going to create a new function called change slots. And this will be a utility function. Oh, sorry. It's not what I meant to do. It's a utility function. It will have actually two inputs inputs, oddly enough, but they will both be type integer. It's a modified old friend of ours, index ref a, which will be an integer, and index ref b. Because in this case, what we're doing is we are switching the item in A with the item in B, and the item with B into the item with A. Literally, it's a swap node. Like, honestly, in C++, this is a bit faster to do. We are going to pull from here, and we are going to promote to local variable. This is index ref a local. Yeah, unfortunately, we're going to have to stick with it being one weird word at the end there. And then we're going to do the same here with index ref b local. So 2 items changing their locations. They are found at these particular indices. This is our set locals for the slots that are swapping. We are going to make sure that they are both in bound of the array, that these are valid slots to swap. All right, next, as I said, we're going to do is check if they're in bound. So we're going to do a branch. And we know if it's an or statement, we know if either one of these is out of bounds. Because if, again, we're going off the true. If either one is out of bounds, then we're going to fail out of this. And we're going to have a lot of fail states. So if we just need one of them to be true, so we're using an or. And what we're going to do is we're going to get our inventory slots data. We are going to get the last index. And in other words, we pass the last index. And we are going to check is our last index, is A less than our last or greater than our last index, or is B greater than our last index? Is it either or greater than our last index? We are out of bounds. We are trying to swap items in slots that don't exist. This is bad. This is cheating. This is a bug. We don't want this. So A goes in the top pin for the top one. B goes in the top pin for the bottom one. I guess it could be B is in the top pin for the top one, and A is in the top pin for the bottom one. It doesn't really matter. So this is our first fail state. Check if in bounds of inventory slot array true equals out of bounds. So what happens if this is true? We're going to do our return node. We're going to have one output. And that will, of course, be a Boolean in this case, which is B changed slots. We leave this as false because we have failed to change our slots. If this is true, if this is false, we're in bounds, then we are going to temporarily store the information in one of the slots in a local variable. So what I'm going to do is I'm going to store the information in the second slot, slot B, in a holding variable. So I'm going to get that slot information. So we're going to get a reference this time because our reference makes a hard we want to affect the actual thing. Want to make sure I'm getting the right thing pretty much. You could do this with a copy. It doesn't really matter. I am using a reference out of paranoia. And we're going to promote this reference to a new local variable called temp holding local. So we are temporarily holding the data of this slot, so reference B here, in our temp holding variable. Why are we doing that? Well, because we're about to delete what's in B here. We're going to replace it with A. So store item in slot quote unquote B in temp variable. B will be overridden first by A. That's the only reason we're storing it, is we're overriding B first. We're moving item A into B. If we do that, then we lose what's in B. So this is holding that information for us. What we're going to do is a very similar thing to our add item, except for we're doing this a bit differently. We are going to, instead of how we did previously with the add item, we're going to get the set array elem or elm or whatever the heck you want to call it. And so this is the main node in our add item. But instead, what we're going to do is we are setting index B. So we're overriding B. And what are we overriding it with? Well, let's get our inventory slots data. Let's move this to the side a bit. We are going to just target that array. Let's put some reroutes in because we will need them. I'm going to put a second reroute in, actually. What we're going to do is we are going to get from this array a reference of what's in slot A. So we're taking the information in slot A and we're placing it in slot B's location. Again, this is why we're storing B here. So override B with item in A. All right, it's annoying me that I did one of these as capital and one of them as lowercase, so I'm just gonna go fix this and make everything uppercase. Then we have to take our temp holding slot here and put it into A's former slot. So I'm gonna duplicate this node, pin this in here, and I could pull from this inventory slots data, but I'm gonna be neat about this and just put that down there. We are doing this at index A now instead of index B, so now we're replacing what was in A, or what still is in A until this point, with what was, past tense, in B. And we're going to use temp holding data. There we go. I guess we could use the add item node and just split this structural pin, but This is restore, in quotes, from temp B in A's, well, that is such a weird way to write this, former slot. Yeah, I'm giggling at the fact there's so many apostrophes. All right, at this point, then we need to update our inventory. So we're gonna get our update inventory, not once, but twice. So I just use Control W to duplicate that, once for slot A and once for slot B. All right, after that, we are going to have another event here that we'll add down the road, but we're gonna do our return. So I'm just making a note in my prep file to come back and actually add that in, because I'll forget. This is how we are splitting or swapping our stacks. Okay, I guess we only had one fail state. I might be thinking of our split stack. Our split stack has definitely a lot of fail states in it. So let's go on and do our split stack. I said split state. So split stack is when we have a stack of items and we want to split it into smaller stacks. This is a utility function, and this is the last one I think we're doing. I'm going to double check in a moment though. We are going to have our old friends of index ref and amount to split, or split amount. So in another amount. By the way, we don't see amount as much as we will index ref, which is why I call index ref our old friend. Split amount. Like usual, we are promoting these to local variables, index ref local, and our split amount local. Split amount local. All right, let's just put that there. Let's put a reroute in, line everything up so it's nice and pretty. Set our local variables. From here, what we are going to do is we are going to check if there is a free slot. Or sorry, we're going to check if the slot we're trying to split is actually a free slot or not, because we can't split an empty slot. This is just a check. So we're going to take our check if slot is free, plug that into there. If it is free, well then, hey, there's nothing for us to split. Plug the index into there, by the way. We're going to hit our first fail state. As you notice, the fail states are early on. This is us checking things. B split successful, which does not have two F's. Oh, wow. Okay, let's just assume I can speak and also spell. Unlike to speak and spell. All right, the next thing we need to do is another check. So this is checking, is there something in the slot? Is there something in the slot? If not, bye-bye. We're not creating things out of thin air. The next thing we want to do is make sure, one, we are not over-splitting. So over-splitting would be if we have a stack of 10 items and we try to split them into a stack of 9 items and 8 items. 9 plus 8, for those of you playing the home game, is 17. So that would add in 7 items. We're going to prevent over-splitting. So the way we do this is we first... Oh, also we want to make sure this is something that's harvestable. I'm not sure why I have that check in here anymore. I'm pretty sure it's how I set up some things later on. You could, I guess, skip the is harvestable. The primary part is we want to make sure we're not over splitting. So we are going to get our index reference local, and we're going to create another new variable at this stage. Another new function. And this function, we're going to pause here and just create it this way, because this is a big one, is our get item info. So get item info. which will be a type of inventory items. This is a pure function. It will have our old friend of our index. Please let me type. Thank you. This is movie phone. All right, so integer. What we're gonna do is we are gonna pull off of here. Actually, no, sorry. We're gonna get our inventory slots first. We aren't gonna set this to a local variable, don't worry. We are going to get a copy at that index. We are going to split this pin because we do need both of these. And cool, this isn't the one that bugged out on me last time I did this. What we're gonna do is we are going to get isValidClass, and we're going to do another not here. This is starting to look familiar, right? What we're doing with this is a bit different. So we are first going to make sure this is an empty slot or not. So we're going to promote this to a local variable. B is empty local. A little bit of repetition. We could improve the polymorphism here. So I just worked out what the prep video for this is going to be because there was no prep video for the last video. All right, from here, from the isValid, what we're going to do is we are going to check. Actually, I'm going to break that for just a moment. I'm going to put that back in there, put a reroute in, and let's just move things to the right a bit. No, I just want this node now. Close enough. Close enough for government work. All right. Oh, that did not come out as nice as I wanted to. We're going to go from that reroute into there. There we go. And from there to there, put another reroute here, move this up. So first, we want to confirm if the slot's empty or not. So confirm slot is empty. And then, oddly enough, we're doing the reverse of that. Check slot is filled. I guess we could put another not in here and do it that way. Actually, I think I did that and it didn't work right. All right, let's do our if it's empty first. So what we're doing is getting item info. If a slot is empty, then we're just returning an empty set of information. So we're going to have three things we return. We're going to return our slot is empty. Actually, I'm going to cheat a bit. I'm just going to delete this isLocal1 first. I'm going to do my other return first. And for this, what I'm going to do is I'm going to move that out of the way. I am going to come off this class here and plug that into there. Actually, no, I lied to you. I'm not going to do that. I am get class default. There we go. My item details will go out that way. I notice we now have that pin there. I am going to just drag these down, line those back up. And I am going to take my amount and slot and plug that into there. So, just lining those up a bit better. We can tuck this under here, and we're passing out our item details with an empty and a 0 if the slot is empty. And in this case, just to be on the safe side, we'll pass this out as well. It'll be false. The slot is full. And here is the item details. We could use our earlier function here from, what is it, check if slot is free. We could just do this and take the index there, but meh, showing you different ways to set this up, I guess. Let's go back to our split stack now that we're passing out this item info. So in our split stack, we are, ooh, hang on one second. I want to go back into here for a moment. I'm going to hide my unconnected pins. There we go. Now it's prettier. Oh, this is bugging out on me. For some reason, this reroute, I think there's a way, I think if we don't use the reroute, we're going to bypass it just for a moment. Yep, it's the reroute. For some reason, in this function, this reroute causes all sorts of weird issues. So, yeah, I don't know what to tell you about that. That reroute is doing absolutely nothing now. Yeah. So, we're going to get item info. There's that function we just made. We care about the first two pieces here. We want this, and we're going to break this. We are going to take the is harvestable and plug into the top. We're going to hide the unconnected pins. We're going to take the amount in the slot. We want to make sure this amount is greater than what we are trying to split. If we try to split an equal amount, by the way, then we're literally just moving the slot. That isn't what we're trying to do here. We're trying to split it. The split doesn't need to be even. You can leave out of 10 items, 1 in the slot and move 9, but it needs to be less than the amount that's in the slot. So, all we're doing here is 1, not over splitting. 2 is harvestable. And the reason we're doing the is harvestable again is, well, I didn't say originally in the first place, but that's due to how our system is set up in general, and the sort of items we can split will tend to be the harvestable ones. Next, what we are going to do is we're going to have our next fail state. If either of these conditions are not met, we're doing our return. There's our second fail. What we're going to do after this is we are going to find a new slot. So we want to find an empty slot. We're going to have a branch off of our node there, and we're going to have our third fail state. So this is the one with all the fails in it. So find new slot. Actually, this is a bit bigger than that. If we find the new slot, we are going to have a new index ref local, and yes, that name was intentional. New index ref local. The original index ref is where the item's currently at. The new is where the item is going, or where the new stack is going. All right, from there, we are going to adjust the original stack. So we are going to use our add item. Let's get our add item event in here, or function in here. And what we're going to do is we are going to take our original index, so index ref local. We are going to do this at this index. So we are going to remove from here the quantity of what we are adding. Oh, that is not what I meant to do. Sorry, give me 1 second. Where are we doing this at? Well, or what are we doing this with? With whatever is at that index. So we are going to get a copy at that index. We are going to put another reroute in. There we go. We are going to split this structure, and we are going to do that with this class. The amount we're going to do this with, well, it's what is ever currently in the stack minus our split amount. So we are taking the split amount from the original and moving that split amount into the new stack. So this adjusts, wow, the original stack. The next thing we're going to do is we're going to add a new stack. So I'm going to duplicate this node of add item. Where are we adding an item to? Well, we're doing it at our new index. What are we adding there? Our class from over here. So we're going to come off this class and just plug that into there. And how many are we adding in? Our split amount. We don't need to worry about our encumbrance because we aren't changing the amount of items we're carrying. So add new stack. The stack could be a stack of 1. It doesn't matter. It's just the new stack or the thing that can be stacked. Again, we are going to update our inventory not once, but twice. Once for the original stack, so it's at the original index, so index ref local, and once for our new index. All right, and then we'll have the other event we have to add in down the road, and we'll do our return. This is the only condition in which our split was successful. Alrighty, that takes us through setting up everything we really need for our inventory system. Of course, we don't have full utility. We can't use items yet. We don't have visual display, but we're now able to add items to our inventory. So we'll start working on setting up our UMG in the next video. The reason why I'm doing the UMG in the next video is it's a short video. We've had a lot of really long videos, and I feel for you on that. I get we have a lot of long videos where we can't see stuff. But let's look at something somewhat pretty and work on our widget. All right, that said, I hope you've enjoyed working on your inventory system, and if you have, please make sure to hit that like down below. Yeah, I'm too tired to even make the joke right now. I saw it pop up. If you have liked this or if you have liked working on your inventory system, if you're looking forward to having a fully functioning inventory system, or you just want me to know or help this channel out, let me know you appreciate this content or help this channel out. You can tell I'm tired when I'm messing up the outro this much. Hit that like button down below. If you want to be here when we're finishing up our inventory system, because the UMG really is the second to last step. Of course, there will be 2 or 3 UMG videos, maybe more. Then make sure to hit the subscribe and notify bell. If you don't hit the notify bell, YouTube might not tell you when the next video is out. And this series has been brought to you by Patreon sponsors like Quad Menson, Haynes, and Rian. If you want access to this project, then consider becoming a Patreon supporter. Patreon supporters at upper tiers will get instant access to any ongoing YouTube project. Patreon supporters at other tiers can get access once projects are completed. That said, if you just want to support the channel, consider becoming a Patreon supporter. And, as always, I look forward to seeing you in the next tutorial, and I hope that you have a wonderful day. I'm an item.